Alright, now let's see how we can implement the repository pattern with Entity Framework. First, I'm going to show you a diagram of the interfaces and classes, and then we'll explore the code. So to start with, we need a repository interface. This interface is like the interface for a collection of objects in memory. So it has methods like add, remove, get, and find. Again, here we're not going to have update or save. Next, we're going to implement this interface in a class called repository. Inside this repository, we're going to have a DB context, a generic DB context. So what you see here is completely generic. It's got nothing to do with our application. We can reuse this interface and the concrete implementation of it in any applications. In context of our application, Pluto, for each entity, we're going to have a repository. So for course entity, we're going to have an interface called iCourse repository. In this interface, we're going to define any operations specific to courses that are not in our generic repository. For example, we can have a method like get top selling courses, or another method, get courses with authors, which uses eager loading to load the courses and their authors. So this is one of the key things here. Anything to do with eager loading or explicit loading is data access concern. Your application code, your business logic should not care how this is done. This is the implementation detail that should happen inside a repository. Your business logic layer, your services, simply tell the repository, give me courses and their authors. And the repository works out how it should be done. Now here, iCourse repository just declares the contract. So we need to implement it in a class like course repository. So in this diagram, course repository derives from our generic repository because a lot of our data access code is similar. But it also additionally implements iCourse repository interface. So it's going to have implementations for these two methods you see on the right side. Next, Unita work. So we need an interface like iUnita work. This interface is specific to our application. So it's going to expose various repositories based on the entities we have in our application. For example, here we have two properties, courses and authors, and the types are iCourse repository and iAuthor repository respectively. And note that here we have a method called complete, which indicates the end of a Unita work. We could call this save, but I personally prefer to call it complete because this is completion of a Unita work. Next, we need a class to implement that. So we're going to call this Unita work. Now let's flip over to Visual Studio and see all these interfaces and their implementations in action. I'm going to take you through every interface and their implementation, but you can also download all the source code in the supplementary materials of this lecture. Let's start with iRepository. Okay, here's my iRepository interface. Note that this is a generic interface where TEntity is a class. Some developers like to have a marker interface like iEntity and decorate their domain classes like course, author, tag, cover, and so on with that interface. Then here you could say where TEntity is iEntity. But I personally don't quite like marker interfaces because it's like fooling yourself. It doesn't bring any value. Anyway, here we have three groups of methods. The first group is for finding objects, the second group is for adding objects, and the third group is for removing objects. So the first method, get, receives an ID and returns an entity with that ID. We also have getAll, which returns all objects, and find, which takes a predicate. This predicate is an expression of func. So this means we can use a lambda expression to filter objects, exactly the same way we use the where method with link. Next, we have add, which adds one object to the repository, and add range, which adds a list of objects. And similarly, we have remove and remove range. So as you see, this repository interface is like a collection. It doesn't have methods like update or save. Now let's look at its implementation. So here's my generic implementation of the repository. Note that it takes a DB context in its constructor, and this is generic. It's got nothing to do with our application, so it's not Pluto context. I have declared this as protected because in derived classes like course repository or author repository, I'm going to use it. Now look at getAll. This method returns IEnumerable. It doesn't return IQueryable. And that's the key thing here. Your repositories should not return IQueryable, because this can give the wrong impression to the upper layers like services or controllers that they can use this IQueryable to build queries, which is completely against the idea of using a repository in the first place. Your repositories should encapsulate your queries so you do not repeat them. So here in getAll, I simply call toList to return an IEnumerable. Now the implementation of other methods like find, add range is pretty similar to using a normal DB context to adding objects or removing them. So nothing special here. Again, you can download the source code and study it on your own. So note that this iRepository and its implementation are completely generic. They got nothing to do with our application. Now let's take a look at the custom repository. So I'm going to show you iCourse repository. So this interface derives from our generic repository interface. So it's going to inherit all those generic operations like add range, remove, get, and so on. But it also declares two additional operations: get top selling courses and get courses with authors. Again, note that both these methods return IEnumerable. So we're going to execute the query inside the repository and return a list of objects to the client. Now let's take a look at the implementation of this interface. So this class, course repository, derives from our generic repository because we don't want to repeat all that code for adding, removing, and getting objects from the repository. So it inherits from repository of course and also implements iCourse repository. So here's the implementation of the methods in this interface. Now get top selling courses does not really have the actual implementation of getting top selling courses. All I'm doing here for simplicity is ordering courses by their full price and getting the first few most expensive courses. So this is not really top selling, but you got the idea. Now look at this method, get courses with authors. This method uses eager loading to load courses and their authors. So we start with courses, then include authors, then order by, skip, and take. This is for paging because we have supplied a page index and a page size. So this is another technique that you can use with repositories. Some developers think they have to use iQueryable so that they can apply filtering in the upper layers like services or controllers. But your filtering for pages shouldn't happen in those layers. It's data access code and should happen inside your repositories. So the way to do that is by passing two parameters here, page index and page size. We could optionally give this a default value to make calling this method easier, like page size is 10 by default. Now here I have declared a property for simplicity. This property is of type Pluto context. So all I'm doing is casting the context that we are inheriting from the generic repository, the base of this class. We're casting that to Pluto context. Otherwise, in every method here, I had to repeat this code. Cast the context first and then get access to the courses DB set. Now let's take a look at the unit of work. So here's my iUnit of work interface. Note that it inherits from iDisposable and exposes two repositories, course repository and author repository. And note that both these are interfaces. This is for testability. So we can mock this interface and these properties in our unit tests. And here's my complete method. Let's take a look at the implementation. So this unit of work, as I said, is specific to our application. So it receives Pluto context in the constructor and store it in a private field here. And this is the interesting part. It uses the same context to initialize both repositories. So the client of unit of work will instantiate a Pluto context, and then we'll use this context across all repositories. Next, here is the implementation of the properties, courses, and authors, which were declared in our interface. The complete method simply calls the save changes on the context. And here's the implementation of the dispose method. So we simply dispose the context. Now, how can we use all these interfaces and classes all together in our application? Let me show you an example. So in a console application, we simply have this using block, and inside this block, we initialize a unit of work with a new Pluto context. Now, this is not how you do it in ASP.NET MVC or WPF applications. There, we don't really use the using block. This is just for console applications. I'll show you how to use this later in ASP.NET MVC and WPF. Okay, now let's go through 3 examples. I'm going to get a course with ID 1. So I start with unit of work. Exactly like how we start with DB context. Now here we have authors and courses. Again, similar to DB context. The difference is, instead of DB set, these properties are repositories. And these repositories, as I explained, are generic. Unlike the DB set, they know nothing about Entity Framework. So this way we decouple our application from Entity Framework. So unit of work.courses dot get, here's the ID. That's it. Another example. I want to get all courses with their authors. So unit of work.courses. And because this is iCourse repository, here we have those additional methods that were declared in iCourse repository. So get courses with authors. First page, and the page size is, let's say, 4. So everything you learned in this course about DB context and DB set and querying applies here. The only difference is you're working with different interfaces that are not part of Entity Framework. Let's go through one more example. Earlier in the last section where I talked about removing objects, you saw that in order to remove an author and his courses, because we didn't have cascade delete, we had to remove the courses first in order to remove the author. So I want to remove an author. First, I need to get it. Unit of work.authors.get author with courses. So this method was declared in iAuthor repository. It's specific to our application. Author with ID 1. Now I need to delete all his courses. So unit of work.courses.remove range author.courses. Now I can delete the author himself. Unit of work.authors.remove author. And finally, I need to complete my unit of work. So changes will be saved to the database. So unit of work.complete. That's how you should use repository and unit of work. So again, download the source code, study it on your own, and if you have any questions, feel free to post them in the discussions area. In the next lecture, I'll show you how to structure your application. I hope you enjoyed this lecture, and thank you for watching.